Welcome back, everybody. Today we're going to talk about section 10.2, the unit circle. There's a lot that goes into the unit circle, and it's impossible to include everything in a single video. So if there's any unanswered questions, definitely follow up with your instructor. All right? But we're going to get the basics down today and get the idea of what the unit circle is and how to get the coordinates around the circle and what they mean. All right, so let's start with the definition of a unit circle. The unit circle is defined as any circle with a radius of 1. And I say 1 unit because the radius could be 1 mile, the radius could be 1 meter, the radius could be 1 foot. Any circle with a radius of 1 unit is considered a unit circle. Now, the reason the unit circle is so special is because... All right, so if we notice that we're counting up by 45 degrees every time, and my radian values are going to be pi over 4, and then it's going to be pi over 2, and then 3 pi over 4, and then pi. So I got 0 pi's, a quarter pi, a half a pi, 3/4 pi, 1 whole pi, and then I'm still counting up by a quarter pi. 5 pi over 4, 3 pi over 2 is 6 pi over 4, and then here we get 7 pi over 4, and then 2 pi is indeed 8 pi over 4. So we're counting up, by pi over 4s. Now the question is, how do we find the coordinates? So for example, if I wanted to find the xy coordinates of that point on the circle, how do I do that? Well, in order to do that, basically what I'm going to do is I'm going to take this triangle, because my circle is getting filled up, and I'm going to pull it out of my circle. All right, so this is the triangle that I'm going to pull out. I'm going to scroll up. I'm going to do it right here. So I have, there's my radius of 1. And this is my 45-degree angle, and this is 90, and this is 45 degrees. All right, now you might be remembering from geometry that there's something special about a 45-45-90 triangle. I can go through the origins of it, but you already did this in a prior class. So we're just reminding folks that a 45-45-90 triangle, you can tell a lot about its sides. So for example, x, x, and x times radical 2. All right. So in this case, with this particular triangle, x radical 2 equals 1. And x equals 1 over radical 2. Then I'm going to rationalize my denominator. So x equals the square root of 2 over 2, which is the x coordinate on your circle. It's also the length of that side. Now, if we notice that whatever the length of this side is the same as the length of that side. So we don't have to go through our calculations again. We know immediately that our y coordinate is radical 2 over 2. So what can we conclude? First of all, we can conclude that this is radical 2 over 2 and radical 2 over 2. But we could also say that the sine of 45 degrees is radical 2 over 2. The cosine of 45 degrees is radical 2 over 2. So you must remember the 45, 45, 90 triangle in an effort to be successful. Now I want to move out of the first quadrant. First quadrant is very straightforward. I would like to move out of the first quadrant, and I want to find the sine and cosine of this triangle that I am doing right there. All right, so we're going to find this triangle. Now, for an angle in standard position, all right, it starts here and goes all the way to here, and that's where I get the 135 from. That's where I get this 135 degrees. Now, the problem is that I can't make a right triangle with a 135 degree angle. However, this angle down here is less than 90. I can make an acute triangle out of that, or right triangle out of that. So that angle that's left is called, if 135 is theta, this is called theta prime. And theta prime is called your reference angle. All right, so I'm just going to go down here, and I'm going to quickly make a drawing. Right, there's my 135 degrees that I'm working with. And there's my theta prime. So theta prime is called the reference angle. Now, we can use the reference angle to create that triangle. If you notice, I just created it. And that reference angle, theta prime, equals 45 degrees. So once again, my radius is 1, right? And then these two are the legs. They're the same number. So if I say x radical 2 equals 1, right? And then x equals 1 over radical 2. X equals the square root of 2 over 2, right? I can put that in for one of the sides of my triangle. Now, here's where it's not as straightforward. Notice that the x side of my triangle, the horizontal side of my triangle, is on the negative x-axis. Okay? So this is going to be negative radical 2 over 2. And this one is going to be, right, I'll call this y just because it's a different number, is going to be positive radical 2 over 2 because it is on the positive side of the y-axis. So I can say that the sine of 3 pi over 4, right, which is the radian way to write 135 degrees, is the square root of 2 over 2. The cosine of 3 pi over 4 is negative square root of 2 over 2. So that's why it's not as straightforward. It's just one little step in between that a lot of people forget about. All right. So here's what you should do at this point. All right. So we know the sine and cosine at 0. We've done the sine and cosine at 45 degrees. We've also done 90 degrees. So we've done all the angles in the first quadrant that we need. We've even done 135 degrees and 180. What I'd like you to do at this point is I'd like you to pause the video, and I'd like you to run through the process with the third and the fourth quadrant, remembering that the fraction won't necessarily change, but it just depends on whether it's a negative radical 2 over 2 or positive radical 2 over 2. All right? So make your triangles, do the math just to go through that process and fill in your blanks. When we come back, we're going to move to another set of angles. All right. So let's move to our next set of angles. If you want to check your work, I'm sure that there is a unit circle in your textbook, and you could also put the sine and cosines into your calculator to see if they match up with what you got doing the math. All right, so I'm going to attempt to make a very, very large unit circle once again. But this time, just going to worry about the first quadrant for right now. Too much by hand. Not good enough. Use my ruler now, which was what I should have done in the first place. There we go. There's 30. I'm going to keep the 45 in there just to remember that we did it, but we're not working with it again. And then 60. There we go. All right. And I can make a unit circle, right? So I need that point, I need that point, and I need that point. Now we've already worked with 0. We worked with 45 degrees. We worked with 90 degrees, right? And continuing around the circle, you've already checked your work for all of the angles where you just add 45 and continue. All right, so now I want to work with this terminal side, which is your 30-degree angle and your 60-degree angle. In order to work to find out the endpoints on your 30-degree angle and your 60-degree angle, we have to work with another special right triangle, the 30, 60, 90 triangle. And we will do this in just a moment. All right, sorry about the technical difficulties, but my 30, 60, 90 triangle, and I'm just going to make an example right here. This is my 30-degree angle. Here is my 60-degree angle, and there's my 90, obviously. And so what we want to do is we basically want to say that the side across from your 30-degree angle, we'll just call that X for now. We'll fill in the numbers for the unit circle in just a minute, but I want to call that X. All right, so the side across from the 30-degree angle is your smallest side. All right, the side across from your 60-degree angle is the next biggest side. You learned that in geometry already. So I'm going to say it's X times the square root of 3. And your hypotenuse is the largest side, and that is 2x. And these ratios hold for any 30, 60, 90 triangle. All right, so if I want to take from my unit circle, and I'll use my ruler. Trying to just get it as good as I can. There's my 30-degree angle. And I'm just going to drop the perpendicular right there. I put 30 on the terminal side of the angle, but the 30 degrees is right in there. And my radius is 1, right? So my radius of my circle is 1. And my goal is to find the XY coordinate of that point. So using my template, I say 2x equals 1, so x equals 1/2. All right, so this side is 1/2 tall, and now I want to find my longer side, my side across from the 60 degrees. So basically what I can do is I could take the 1/2, multiply it times the square root of 3, because again, using my template gives me the square root of 3 over 2. So then this side is square root of 3 over 2. All right, so the way I can finish this off and bring some understanding to it is saying my x is square root of 3 over 2 my y is 1/2. This is a point on the circle, right? And I can even say that the sine of 30 degrees equals 1/2. The cosine of 30 degrees equals the square root of 3/2. All right. So, how do you feel about that? Okay, I hope good. What I'm going to do now is I'm going to try to make a super large circle. Actually, I'm going to try to use my ruler as much as possible now because my circle is going to get filled up pretty quickly. There we go. There, and there we go. And if I go to shapes, I don't see any circles. Nah. Let's see what that's a terrible circle. But let's see, I can make it bigger like this. And again, we can put in our 30-degree line. There's our 45. And there's our 60. There's 90, right? Told you these things fill up very quickly. So here's 0, 30, 45, 60, 90. Now notice I'm not forgetting about the angles that we've already done. We're just not necessarily doing them again. So then after 90, I get 135, right? And then if I'm, actually, you know what? It's not 135 is next. It's 120. Right, then 135, then 150, and 180, and then 210, 225, and 240, then 270, then 300, 315, and 330. So at this point, again, I'm going to ask you to pause the video and I want you to fill in the radian values right next to your degree values. That way you get practice and you can relate them to each other. All right, so I'll be back in just a minute. All right, so hopefully you're able to fill in the radian values. I'm sure that you can check them with your textbook, but you guys are experts at that by now. All right, so here's what I want to do. I want to try to find, again, one that's not so straightforward. I'm going to try in quadrant 4. So I'm going to call that angle 330 degrees. And we know that 330 degrees is how many radians? Which would be 11 pi over 6 radians, right? So first of all, we need to know what theta prime is, right? In order to make our triangle, I need to know if I'm dealing with a 30, 60, 90 or 45, 45, 90. So doing some quick subtraction, I can subtract 330 away from 360, and I know that theta prime is 30 degrees. All right, so I'm going to pull this triangle out, and I'm going to call it 30 degrees, and this is 60, 90. right? And x is going to be positive, but the y value now is going to be negative, because if you notice, we're going down the y-axis, right? So we're looking for that coordinate here, or we're looking for this xy coordinate here. So that y value has to be negative. All right? So again, my radius is 1. The side across from 30 degrees is going to be half of that, right? So y equals negative 1/2. A lot of people want to put in positive 1/2 because they just do the math. You have to know the location on the coordinate plane. And if I take that 1/2 and I multiply it times the square root of 3, I get square root of 3 over 2. And again, the location on the coordinate plane says I'm on the positive x-axis, which means that that number must be positive. So the cosine of 330 degrees equals the square root of 3 over 2. The sine of 330 degrees equals negative 1/2. All right. So all of these values can be found if you were to Google it. I freely admit that. I've never been one for memorizing. I've always been one for trying to show where things come from or show how to generate things. I definitely encourage you practice the unit circle and ask questions, because like I said, you can't answer everything in a single video. All right. In the next video, we'll talk about the other 4 trig functions. Right now it's just sine and cosine. So practice your unit circle, and I'll see you next time to do the other 4 trig functions. Thanks for listening, and I'll see you next time.